So this is lesson 8.2, Pythagorean Theorem and its Converse. And I know we have been working with Pythagorean Theorem a lot so far, but it's definitely something we need to continue to practice with so we have it down very well, because that is going to help us in these next units over trig. So we have our right triangle. That's what Pythagorean Theorem works with, is a right triangle, A and B being the legs, C being the hypotenuse. So let's go ahead and label always across from our 90-degree angle is our C. Again, the hypotenuse is always C, the longest side. A and B can be either of the legs. So then we are going to take our 4 squared plus our 7 squared, setting it equal to our C squared. So 16 plus 49. And then we add those together, and we have to undo the squared that's with the C. So rooting is going to get rid of the square, and so C is the square root of 65. If you want to try this one, go ahead and pause and check when you're ready. And you should get square root of 80, or if you simplified it, 4 radical 5. Some common Pythagorean triples or sides of a triangle would be 3, 4, 5, 5, 12, and 13, 8, 15, 17, 7, 24, and 25, and then here's some more listed as well. So if you kind of memorize those, you can help yourself to recognize and solve them a lot quicker. So this one is actually 2 times 13. This one is actually 2 times 12. So we have kind of a 12, 13, and then the other leg would have to be 5. Well, it would be 2 times 5, which would be x is 10. And you could again solve with Pythagorean theorem, but see how quickly we were able to solve that by kind of recognizing some Pythagorean triples. It can go a little bit quicker. Let's take a look at a standardized test question. It's Pythagorean theorem. We can see those sometimes happening here. So we have a 20 and a 16, and so this is 4 times 4. This is 4 times 5, so 4, 5, and this would have to be a 3, but we need to take it times 4 since that's what's happening on the other one. So 4 times 3, oh, that would be 12. And again, you can use your Pythagorean theorem formula, but much quicker if you can memorize some of those Pythagorean triples. So now, the converse of Pythagorean theorem, if we know it's equal, we know it's a right triangle. If we know that c squared is less than a squared plus b squared, then it's an acute triangle. If c squared is larger than a squared plus b squared, then it's obtuse. Okay, so c squared being less than acute, c squared being greater than obtuse, and then c squared, if it's equal, we know it's a right. So let's go ahead and classify down here. We have a 9, a 12, and a 15. So we know we're going to compare the 15 squared to the 9 squared plus 12 squared, because we always do the bigger one as our c. So this is 225, and then over here that's 81 plus 144, and we're going to figure out what that relationship is. So 81 plus 144, well, that equals 225. So when it's equal, it is a right triangle. So if you want to try this next one, go ahead and try it. 13 squared compared to 10 squared plus 11 squared, and see what that relationship is. And this is 221, which is greater than 169. So the c squared is less than, which means this is an acute triangle. So if you can recognize again your Pythagorean triples, and it's a right triangle, you can go ahead and fill a lot of these in pretty quickly. So 5, and then this should be 12. Again, you can use your a squared plus b squared equals c squared if you're not sure until you kind of get that down. This one, not quite recognizing a Pythagorean triple there myself. So 4 squared plus x squared is equal to the hypotenuse 16 squared. So I'm going to subtract 16 from our 16 squared. That's going to give me x squared equals 240. So x on this one is 4 square root 15. So it's not a Pythagorean triple, but we can still find x using Pythagorean theorem. Now this one, dealing with some fractions, so 4/9 squared plus x squared is equal to 8/9 squared. So we can go ahead and solve, and you can use your calculator if you need to. So x squared is equal to 65/9. So if we square, that's 16, that's 64, and squaring that and then subtracting it from that, which is the same base, so it's pretty easy to do that. And then doing the square root. So x is going to equal the square root of 65/3. So we'll square root the top, square root the bottom. Looking for x on this one, we can recognize that this is a 3 times 3. This is a 3 times 4, so we have a 3, 4, 5, and then we need to take it times 3. So 3, 4, 5 triangle, and then taking it times 3, that would be x is 15. And then over here, this is 8. So we have an 8 and a 15, and we need to figure out what this side is, and an 8 and a 15 means the hypotenuse has to be 17 with that Pythagorean triple. On this next one, we do need to do some solving though, so it's going to be an 8 squared plus an x minus 4 squared is equal to x squared. And then we need to do some foiling, because this, we can't distribute that, we have 2 of them. So it's really like x minus 4 times x minus 4, and we need to FOIL, take a 2 by 2. So that's going to be x squared minus 4x minus 4x plus 16, which is x squared minus 8x plus 16. So see, we can't just distribute that. That's not how we multiply that. So this is 64 plus x squared minus 8x plus 16 is equal to x squared. And then we can go ahead and subtract x squared from both sides, which is going to cancel out there. And then combine our 64 and 16 since they're on the same side. So really we have negative 8x plus 80 is equal to 0. Subtract 80, and then we have negative 8x is equal to negative 80. Divide both sides, x is 10. So that would make this 10 and this 6. To support the basketball forms, the right triangle here, what would the length of the horizontal portion be? So we're going to go ahead and set that up. 1.5 squared plus x squared is equal to 10/3 squared. So this is 2.25 plus x squared is equal to 100/9. And then we're going to go ahead and subtract that. So x squared is equal to 8.861. And so x is about 3 feet. 2.9767, so we'll just say about. Okay. Looking at this next example here, we need to set up our ratio here of 4/7, and that is going to be our vertical over our horizontal. And then we need our vertical length over, we know our horizontal is 14. And then we can go ahead and cross multiply. So the vertical is going to be 7b is equal to 56, which means b is 8. So vertical distance being 8, horizontal distance was 14. And then we can go ahead and use Pythagorean theorem. So 8 squared plus 14 squared is equal to our length squared, or c squared. So that's 260, and then square root, so our length is approximately 16.1 feet.